All right, hello and welcome. This is going to be a 4 video series, Algebra 2 preparatory mini crash course. Hopefully to give you guys some exposure to Algebra 2 before you head into it during your school year. And this is the first video, part 1 of 4, focusing on linear equations and systems. So a quick overview. We're going to have 4 videos. Part 1 is going to focus on linear functions, equations, and systems. Part 2 is going to focus on quadratics. Part 3 is going to be focusing on factoring. And part 4 is factoring continued, because factoring is a big part. Some sources we're going to be looking at are going to be Khan Academy, the Get Ready for Algebra 2 section, as well as the Algebra 2 section. Highly recommend checking these out on your own or referring these to support, whether it's like during your school year or like during the summer as you're getting ready for it. Khan Academy has a very high budget for creating these videos and a lot of planning, a lot of detail going into this resource. So use it. It's completely free. Highly recommend. Looks like this. And this is what we're going to be focusing on mainly with our mini crash course. We're going to go over a small portion of it. We're going to go over some of the polynomial stuff with factoring here, little linear equations here, some quadratics over here, and then the rest is still available for you to check out on your own. Definitely would recommend. This is really helpful during the school year if you ever want any in detailed explanation. Yeah, just explaining this resource out there, really helpful. It's going to help you more than anything in the world if you really need the help here. Anyhow, basically my crash course here, or this video series, is essentially just introducing you to this resource and going over really briefly to see, where your strengths and weaknesses may lie. All right, so these are some problem sets that are some problems in this problem set after this part 1 video. This is what they look like. And essentially during this video, I'm going to go over variations of these problems. The numbers are just tweaked a bit, and hopefully it'll help you out. The practice doc looks like this. And then if you have trouble, you can check out the specific Khan Academy video that's linked right here. And that should be able to help you if you ever get stuck. All right, so let's get into the problem solving now. First up, we have a linear system of equation, linear equation, sorry, with variable on both sides. So with this kind of linear equation, where we have a variable on both sides, we want to combine them, right? We want to combine like terms with like terms. And in that process, because it is an equation, what we do on the left side, we have to do on the right side, because at all times, right, we want our left side to equal our right side. Did I say, yeah, left side equaling the right side, right? So this is important, right, because we want to maintain that balance. I'm sure you guys gone over this during Algebra 1, but this is just good review. So heading into this problem, right, with these fractions as well, we want to simplify this problem into like a form that we can understand. So first things first, we want to get rid of these fractions. How we can do that? We look at the common denominator, something that will get rid of both of the fractions, and this number is going to be 8. So how we're going to tackle this is I'm going to multiply by 8 and multiply it by to the entire right side, right? And then same to the entire left side, sorry. And then we're going to multiply this 8 as well to the entire right side, right? And make sure we're consistent. We multiply 8 times 3x, so that's going to be a 3x. And then we want to also multiply it to this plus 2. So 8 times plus 2 is 16. And then same thing for the right side, 8 times 1/4 x, 2x, 8 times -1, -8. All right, now we've gotten into this stage. We've got rid of the fractions. We've converted this equation into more of a form that we're more familiar with. We can start combining the like terms to like terms, right? We can combine these x expressions, and then we can combine these constant number expressions together. So how we can do that, right? We can subtract 2x from the right side, right? This is something we're introducing. But then keep in mind that what we do to the right side, to make the right side still equal to the left side, we have to do it to the we have to do the same thing, right? So these are like terms that we have to do equally. And then if we subtract, right, these cancel out, right? These disappear. We get a -8 here, right? And then on the other side, 3x minus 2x, we get an x, carry over the 16 plus 16. And then from there, what we can do is isolate x on one side. We can do minus 16 here to get that x. And then once again, on the same side, we have to do the same thing, also on minus 16 to get x equals -24. Moving on, we have a similar problem, but with a slight variation. The variables now actually in the denominator. But no fear, we can apply the same principles. It's a little more tricky, right? We have the fraction, we're uncomfortable with that. We also have the variable in the denominator, also uncomfortable with that. So let's work to get rid of the fraction and let's get the variable back up into the numerator. So we can, how we can do this, right, is we can multiply by the denominator, multiply it to both sides. Here's how it's going to play out, right? Similar with why we chose 8 is a common denominator that can get rid of 3/8 and 1/4 fraction, but this time we have an x. So we also want to add the x to get rid of this x out of this denominator, right? So if we multiply both sides by 8x, we apply it to the left side, and then we have to do it as well to the other side over here. And then how this is going to work, right? We multiply 8x to the 3/8 over x, and then that's going to give us a 3. And now, so we're satisfied, right? We kind of gotten rid of the fraction. We've gotten rid of the variable in the denominator in one fell swoop. But make sure you don't forget to do it to every part of the left side. So now we have 8x times 2. So that's going to be 16x. And then same thing for the right side, right? 8x times 1/4. We're essentially going to get this crossed out, right? 2. And then we're going to get 2x, right? But don't forget, right? We don't want to forget 8x multiplied by the -1. So essentially, sorry, that looks bad right here. Essentially, we're going to get this multiplied out. This is going to be 2. Sorry, my bad correction. But this is going to be 2, and then minus, right, -1 times 8x, which is going to be a -8x, right? So essentially what we can do here then, we've gotten back to a familiar land where we have just a linear equation, and then we can combine like terms with like terms. Get to this 1 equals, right? So we can -2 from both sides, right? Combine those like terms. So we got 1. Let me actually make it more organized here. Say we can -2 from here, -2 from here, right? Keep it balanced. 1 plus 16x equals 0 minus 8x. And then to combine the other variables on the other side, we can do -16x, -16x both sides here. And then essentially it's going to look like 1 equals -24x, and then x is going to equal -1/24. How you reach -1/24 is you can divide both sides by -24 to get x equals -1/24. Moving on, we can solve a system like this using parentheses. Looks a little more scary, but same concepts apply. Keep in mind, first thing we want to look to is to get the x's together, isolate it to the side, and keep in mind every time we do something to one side, we do it to the other. So the way we can first do this is essentially we can like multiply these out and then make sure it stays consistent. So we can get rid of these parentheses to convert it into a form that we're more familiar with, right? So we have 15, right? And then we have, this is essentially a -1, right? So we can do -1 times 4x. So that's easy enough, -4x. Now we have to keep in mind, right? Because of these parentheses, it's a whole unit. This -1, right, is essentially multiplying to -4 to 4x. and then -1 times 6. So this is going to turn that into a -6. And then same thing on the right side, we're just multiplying things out to get rid of these parentheses to make our equation easier. So 3 times 3x, just 9x, and then 3 times 3, just 9. Now we're back to a linear equation that we're familiar with, and let's start combining like terms with like terms. So here we combine the x's by adding 4x to both sides. We do this on the left side to get rid of x, so we have 15 then minus 6, which can be combined to 9, and then we combine these x's, which is 13x, and then we add 9. And then we can subtract 9 from both sides, minus 9, right? And then a minus 9 here. And then essentially what we get is 0 equals 13x. And then we can divide 13 by both sides. And then we get x equals 0. So moving on here then, we have a system of linear equations. And the method we're going to be solving this is through substitution. Okay, so in this, what's unique about a linear system of equations is that there are two variables now. We have x and we have y. While we're through the method of substitution, essentially what we're going to be aiming for is how can we replace a variable with a certain expression. What this means is how we can possibly convert this equation into a form that looks somewhat more like a x equals and then some kind of y expression, right? This is just for example, like 15. We want to get into this form. Why? Once we get into this form, we can plug it in, and I'll show you this process as we go along. Once we get into that like an x plus like 15 like y or plus 15 form, essentially what we can do is plug this into our second equation and replace all these x's to kind of get a better understanding of how to solve this system. So let's start with an easier problem over here. So this is like a more simplified expression, and whereas this expression looks a little complicated. So the first step, every time before I tackle a problem, I'm always trying to look to see if I can like simplify the expression. Here you can, right? We have some x's here and then some y's here. We kind of want to, we know we can combine these from past problems we've done, and by doing so, we can make our equation a lot simpler. So, right, so we just rewrite it, 5x minus 3y equals 7x minus 8 plus 3y, right? So let's try to combine like the x's together and the y's together. So what we can do, right, is we can do like, for example, negative 5x from the left side to get rid of this x and bring it completely over to the right side. So what's done to the left must be done to the right, right? Kind of do this, and then we have the x's are gone completely, and then we have a minus 3y equals a 2x, and then minus 8 plus 3y, right? We've combined the x's, it's a little slightly cleaner. Let's do the same thing for y's, right? What we can do here, right, we can bring the y's to the other side, for example. We can minus this 3y, get rid of the y's here, and then what's done to the right must be done to the right, to the left, right? And then essentially, right, what we get is this can be negative 3y minus negative 3y, which is going to be negative 6y equals 2x minus 8. And we've kind of created a more simplified version that we can work with in this system of equations. So let me just bring this over, right? This is still staying the same. So we have negative 3x minus 2y equals 3 over here. And then we have a negative 6y equals 2x minus 8, which is what we simplified earlier. So, we can actually simplify this even more because the coefficients or factors, they're all divisible by 2. So what we can do actually is divide the right side by 2 and also divide the left side by 2 to keep it equal. But then by doing so, essentially we get x minus 4, and then we get a minus 3y. So then we move up here, and we can bring it over here, and our easier set of equations is this. And then looking at this, well, keep in mind, right, we want to have some kind of x equals some kind of like y equation, or we could do vice versa, whichever one turns out to be easier. But essentially what we want to do here is we can take this equation. It looks easier to deal with because I have a single x here that I can easily isolate. And what we're going to do with this equation is we're going to add 4 here to get rid of the 4 to the other side. And then what we can do is x equals, and it's going to be a negative 3y plus 4, right? Let me rewrite that just to make it simple, flip flop. And then we can just do like 4 in front minus 3y, okay? So this is something that we've achieved. We've created a simple expression that x equals. And now the interesting thing about that is now we can take this x value and substitute it into the other equation, right? So let's see how this works, right? We're essentially going to replace this x, right, with this, right? Because 4 minus 3y equals x, we can replace this x with this, okay? So how that's going to look is, right, let me just bring down the whole equation back down just to make it easier to see. So we're replacing this x with the other x we've kind of decided from the other equation. So it's going to look like minus 3, and then it's going to be 4 minus 3y, right? We're getting rid of the x. There's no more x's. Minus 2y equals 3. Now what we've gotten is a point. This is a problem that we can solve, right? We only have one variable. All we have to do is, once again, see these parentheses. It makes us feel uncomfortable. Let's get rid of them, right? Let's multiply it out. Minus 3 times 4, minus 12. Minus 3 times minus 3y is positive 9y. And then minus 2y, and then equals 3. Let's combine our y's, combine the like terms, right? We can add 12, right, to both sides. And then we can combine these two as well. So this gets rid of that. Then we have 7y equals 15. And then we can solve for y and get y equals 15 over 7. Now we can go back. This was subbed in. Now we can sub this in into this equation, right? Essentially, we're going to have x equals 4 minus 3, right? And we have y is 15 over 7, so we can place this y here with 15 over 7. And then essentially what we can do is multiply it out. The math's a bit messy here, this problem, but we have x equals 4, and then we can just do minus 45 over 7, and then you can do, do whatever mental math or, write it out. I'm not going to do that, do a calculator, but you can see that this number is going to form some kind of fraction or mixed number over here. And then we have our y, we have our x, and we've essentially solved for x and y for this problem. All right, so last problem of the set, we're almost done. It's a system of linear equations as well, but a different strategy to attack this. Hopefully less messy than substitution. Doesn't work all the time. It only works if you can see the pattern, but here's how it works. Essentially, we're going to be adding or subtracting these two problems together. How is that going to work? The whole point is to add or subtract these two equations together in order to eliminate, right? Hence why the strategy is called elimination, is to eliminate one of the variables. How can we do this? If we were to subtract, right, these equations right now, we would get a leftover x, we get some negative 8y over here. We're not eliminating anything. So the question to ask, right, or the thing how we can do this is, how can we manipulate one of these equations, right, to have this expression or this expression, these two variables equal each other, so we can add the two equations together. Here's what it's going to look like, right? So here I look at this 2y and I kind of see oh, I can multiply by this 3 by 3, right? And it will equal 6y, and it makes the same. And then we can possibly do some addition or subtraction of these two equations to figure it out. So with that said, I'm going to go and try with a 3. So I'm going to multiply 3 times our left side, right? It's a y. And then what we do to one side, we have to do to the other. So also 3 times 11, right? So then what we're going to get, right, is 3 times 2x, 6x, plus 6y equals 33. And then let's bring down this other equation in our system that we haven't touched. 6y plus 3x minus 6y equals 12. All right, so now x's aren't necessarily the same, but the y's look somewhat the same, and here's a way we can combine them, right? So in a way, we're going to draw this big line, and here, right, because this is a positive 6y and this is a negative 6y, we can add these two together to cancel each other out. So I'm going to kind of do a big plus sign here. So essentially, it looks like, right, this 6x plus this 3x, right? So we're going to get a 9x here. And then here, we're going to have a plus 6y plus a negative 6y. So that's actually going to give us 0y, right? So basically non-existent. And then we're going to do a 33 plus 12. So that's going to be 45. And then, right, we can, to isolate the x, we divide by 9. We have to do it by this one side to the same side. So so this crosses out. And then we get x equals 45 over 9. Do the math, divide, x equals 5. So we found what x equals, right? Now the next part is to find out what y equals. Well, we can kind of do something what we did earlier, right? Substitution. We can substitute this x equals 5 into this equation or this equation, either or. I might just pick this bottom one, right? 2x plus 2y equals 11. We can replace this x with a 5. Plus 2y equals 11, right? This becomes a 10. And then, so this becomes a 10. And then we want to isolate the y, right? So we can minus 10, right, on both sides. Right, this disappears, so 2y equals 1. And then what? We could divide both sides by 2, right? So then the 2 cancels out, and then y equals 1/2. And we've solved that equation, right? So we were able to manipulate this one of these equations to get the y variable equal to each other or similar in value, and then essentially we're able to add them to cancel out. So yeah, that's essentially what I have for you, and I'd suggest trying out the practice problems if you can, and if you're having trouble with that, you can definitely check the Khan Academy videos. I've linked them here. The format is very similar, so I went over the problems pretty quickly. So Khan Academy definitely goes over exactly what I went over, but in much better detail and much more clarity. So yeah, hopefully I'll see you guys in part 2. Part 2, we're going to go over quadratics, radicals, more square roots, on the simpler side of things, but also equally as important. Have a good one.